Alright, so this is the second video for section 8.1, and if you haven't watched the previous video, please do that first because this won't make sense if you don't. But we left off the last one doing example 4. So here's kind of the monitoring progress that goes with example 4, so if you feel like you need extra practice, go ahead and pause this video, work these out, and then I'll show you what I got. Alright, so this is what I got. So I noticed each one of these, like the first term is 5 times 1, second term is 5 times 2, third term is 5 times 3, and so on and so forth. And I end at 100, which is 5 times 20. So my rule is 5i, and I'm going from 1 through 20 in the sequence. Okay, and then this sigma here tells me I'm going to find the sum of all of those. Okay, kind of same thing over here, but this time my first term is 6 to the first, second term is 6 to the second, third term is 6 to the third, so on and so forth. And notice my ... means that I continue to go on and on and on. There's no stopping point. So that's why I went from I equals 1 to infinity. My rule is 6i, and then once again, my sigma tells me I want to find the sum of all of those. All right, let's look at example 5 now, okay? So I have my rule, and notice I'm going from 4 to 8. Okay, so I'm going to say a sub 4, a sub 5, a sub 6, a sub 7, and a sub 8. Okay, and then I'm going to put each of these in for k here. So this equals 3 plus 4 squared. This equals 3 plus 5 squared. This is 3 plus 6 squared. This is 3 plus 7 squared. And this is 3 plus 8 squared. Okay, now 3 plus 16 is just 19. This is 3 plus 25, which is 28. This is 39, 52, and 67. Okay, and then this sigma here, this funky looking like backwards E type thing, that means I have to add all these, so I find the sum of all of them. And if you put that in the calculator and you find the sum, I get 205. So that would be my answer. Okay, so I want you to go ahead and pause this, try B on your own, and then I'll go over it. All right, this is what I got for me, B. Now we're going from k equals 3 to k equals 9, so I have a sub 3, 4, 5, 6, 7, 8, 9. And then when I plug those in, I get 11, 15, 19, 23, 27, 31, 35. And then once again, the sigma tells me that I have to find the sum of all of those. So when I add all those numbers in green, I get the 161. All right, so this slide shows you some very important formulas that we can use. And there's 1, 2, 3 here. Now these formulas will be provided for you on a test, but you will have to know what you use them for. So like you'd get this, and you'd have to know how to use it, or you'd get this and know how to use it, or you'd get this and know how to use it, okay? So make sure when you see these, you just know how to read them. All right, if we look at example 6, it says, as part of an experiment, a teacher gives 1 paperclip to the first student to enter the classroom, 2 to the second student, 3 to the third student, so on and so forth, until the 25th student receives 25 paperclips. What is the total number of paperclips the teacher gave the students? All right, so if we go back to here, obviously, we just want one after another, right? So our series would be 1, 2, 3, 4, so on and so forth until we get to 25. Okay, so this would just be term 1, term 2, term 3, term 4, term 25. So our rule would just be I. Okay, so notice we have a formula that we could use when our rule is just I, and it is right here. Okay, so we're going to use that. All right, so that rule, if we write it here, is from I equals 1 to n of I. That's going to equal n times n plus 1 over 2. Okay, well notice here, we're starting at 1 and we're stopping at 25. Okay, so 25 is our n. So I would find the sum by 25 times 25 plus 1 over 2, which is 25 times 26 over 2, which turns out to be 325. So the teacher would end up giving a total of 325 paper clips out. All right, guys, let's look at these other examples here. Okay. So on A, we have from 1 to 18 of I squared. We want the sum of that. So if we go back to here, that would be this formula right here that we would use. Okay. So the formula that we will use here is n plus 1, 2n plus 1 over 6. Okay, now once again, I just got that straight from this formula here. See where it says I squared? Okay. Now our n, guys, is our 18. Okay, so I would just plug 18 in for n, so 18 plus 1, parentheses, 2 times 18 plus 1 over 6, which is 18 times 19 times 37 over 6. And if you put that into your calculator, you should get 2,109. Okay, so if we add up all the terms from 1 to 18, we would get 2,109. All right, let's look at B now. Okay, now notice we don't start at 1 here. Okay, we have this formula from I equals 1 to infinity of I, and that equals n times n plus 1 over 2. Okay, but we don't need the first through 12 terms. We only need 13 through 27. Okay, so think about it this way. What this represents is A13 plus A14 plus A15 plus ... plus A26 plus A27. Okay, so basically if I find from 1 to 27, okay, and then I subtract A1 through A12, that would give me term 13 through term 27. Okay, so this is going to equal 27. If I find all of them from 1 through 27, and then I subtract from term 1 through 12, that would give me what I need here. Okay, so this would be 27 times 27 plus 1 over 2. That'd be this here. And then minus where my n is 12, so minus 12, 12 plus 1 over 2. I get 756 over 2 minus 156 over 2, which is equal to 600 over 2, okay, which is just 300.